The Strategic Air Command of the United States Air Force faced many challenges during the 1950s and 60s. It was during this time, the heart of the Cold War and nuclear arms race, that the Strategic Air Command was compelled to hone its ability to defend and deter enemy nuclear aggression. Recently developed missile systems such as the Atlas and Titan I soon became obsolete because of their inability to rapidly respond. So, development of the next generation ICBM was initiated. Titan II, the LGM-25C, a two-stage, liquid-fueled ICBM, was being developed by the best the United States Air Force could find, the Glenn L. Martin Company. Development of the Titan II was begun in late 1958, and by early 1963, successful silo launches proved the efficacy of the program. Near the end of 1960, even as the scientists and engineers at the Martin Company were drawing up plans for the missile, the U.S. Army Corps of Engineers was tasked with coordinating the construction of the 57 massive underground missile complexes, which would soon house these atomic-age weapons. Air Force bases in Arizona, Kansas, and Arkansas were selected to host these 54 newly minted Titan IIs in units referred to as Strategic Missile Wings and Squadrons. 3 other Titan II missile complexes would also be built at Vandenberg Air Force Base in California to serve as training and test launch facilities. The LGM-25C would carry a nuclear payload of over 9 megatons, comparable to 600 times the yield of the atomic bombs used at the close of World War II. A nuclear warhead of this magnitude had never been dreamt of and was capable of laying waste to 900 square miles individually. Each missile complex was strategically placed roughly 8 miles from one another to decrease the chance of multiple launch facilities being knocked out in the case of an enemy nuclear strike. As soon as the architects and engineers finished the blueprints, manufacturing and construction of both the missiles and the complexes began. Concurrent development of the Titan II and its underground home posed new issues that had not been experienced before. Even small changes to missile design could affect the construction of the underground silo and control center, necessitating ripping out completed projects and starting over again and again. It was not uncommon to hear the phrase, "What do we tear out today that we installed yesterday?" from those that helped build these complexes. It took a small army of tradesmen and laborers from many vocations to complete these gargantuan projects. Welders, pipe fitters, steel workers, electricians, carpenters, HVAC specialists, heavy equipment operators, mechanics, and many more. Each worker knew that their efforts in this project were helping to further their nation's position in the arms race with Russia. No expense was spared in the construction of these sites. It is estimated that nearly $13 million 1960s dollars were spent just to construct each missile complex, with an additional $2.5 million for each missile. If these same ICBM complexes were made today, it would cost upwards of $150 million per missile complex. The entire project of building 57 Titan II launch facilities with the missile installed would currently cost roughly $8.5 billion US dollars. Over 15,000 men across the United States were involved in the construction efforts of Titan II. Each underground structure of the Titan II complex was hardened, meaning it was capable of withstanding a nearby nuclear explosion. The excavation area, often referred to as the bathtub, was usually 400 feet long, 200 feet wide, and 40 feet deep, depending on soil conditions and strength. Some bathtubs were much smaller due to the presence of shale and stable rock, rather than the less stable sandy and gravel soil. Excavation was continued below this point for the launch control center and missile silo, the silo being excavated nearly 155 feet below ground level. Each silo was reinforced with nearly 850 tons of rebar, ranging from 1 inch to 2.5 inches in diameter. The silo concrete pour generally took about 3 days to complete, as the cement was added at a rate of 1 to 2 feet per hour continuously. Once the rebar was encased by concrete, it made what seemed an impenetrable wall on these structures. Each structure was encased in quarter-inch steel plates to help the facility resist the ensuing electromagnetic pulse following a nuclear blast. This steel shell would ensure sensitive electronic equipment would still function after such a blast. The top 25 feet of the silo walls were nearly 10 feet thick to accommodate the 1.5 million pound silo door which would soon rest upon it. Inside of this underground vertical concrete tube was poured another tube referred to as the launch duct. This launch duct was 26 feet in diameter and had a wall poured at 18 inches thick. Measuring from the ground level to the bottom of the sump area, it was nearly 150 feet deep. The silo door was constructed from 3.5-inch thick steel plates, welded together in an egg carton fashion. Each silo door required about 37 tons of welding rod to weld each joint together. The door was assembled over 100 feet away from the silo and was eventually rolled into place upon completion of welding. The bottom surface of the silo door was required to be perfectly flat, or to within 1/16 of an inch throughout. When active, these Titan II silo launch doors were required to open in less than 20 seconds. These doors were also required to be capable of opening with 50 tons of rubble and debris on top of them, as well as being capable of moving past 6 inches of debris on the ground in the event of a Russian nuclear attack. The Launch Control Center, or LCC, was a 3-level dome structure. The foundation of this structure is nearly 8 feet thick, made up of concrete, reinforced with similar rebar to that which was used in the missile silo. Each piece of the steel structure was prefabricated off-site and was assembled like an erector set, with the dome being poured as the last step. The Launch Control Center measured 37 feet in diameter and 42 feet tall. The steel structure which made up each of the 3 levels was suspended by giant springs, which allowed for shock isolation in case of a nearby nuclear blast. Because this structure was capable of up and down and lateral movement, all plumbing, electrical, and communications connections needed to articulate and move. The dome portion of the LCC was eventually buried about 10 feet below ground level. The blast lock area, which consisted of 4 6-ton blast doors, was incorporated for security purposes. Each of these blast doors would be locked by 4 large pins, which would secure the doors in place. Only one of the doors would open at a time until the crew inside unlocked the next. These doors also protected the launch crew from the blast of the missile as it was launched from the silo. Excavation and cement work on these complexes was normally completed within 7 to 10 months, depending on difficulties experienced along the way. Many sites in Kansas and Arkansas required pumps to run constantly within the excavated area due to high water table levels. Installation of electrical, plumbing, HVAC, and other systems generally took another year at each site. The final steps to complete these launch facilities were assumed by the Air Force. Air Force personnel installed the electronics, communication systems, and soon after, the missile itself. The 390th Strategic Missile Wing, based at Davis-Monthan Air Force Base in Tucson, Arizona, was ready to launch 18 Titan II missiles by October of 1963. The fact that these bases, which began construction in December of 1960, were ready for launch within just 3 years is simply astounding. By the end of the project, it was found that each complex used 2,255 tons of steel and about 8,400 cubic yards of concrete. With the help of so many hardworking and highly skilled Americans, these 57 Titan II missile silos became operational within only 4 years of this missile program's inception.